July and August.
See, I
One
guess
of them.
your country is a very heat country, right?
Yes.
Atmosphere and temperature is very high compared to
Yes.
other countries.
Right. So the AC. Even now in the winter, I'm turning on the AC.
Even winter also, you are turning on the AC.
Yes.
Okay, fine. So then here we have to do some.
If if it's too much, we can do like a small house.
Yeah,
There's
I think this one is not. I think whatever you said, 3.3 kilowatt per month. It's for a huge means it's a bigger house.
uh it's
Bigger
the
house.
regular size, not a palace or something. No, not a big house. It's a regular. Oh, in my country, yes. Uh,
Yeah, see, okay, because you people are running parallelly. Most of the 99% houses have the AC, right?
right. Yes.
99%. Only 1% rare where the poor people are there, they don't have that much, then they will use refrigerators or coolers.
Yes. Right.
So then most of the people, 90%, not 99%, 90% they have refrigerators, right? Sorry, these air coolers.
Yes. Yes.
Air coolers. So then this air cooler power is, I think, more than 1500 watts. It requires.
Yeah. Per hour is like 5,000 watt, I think. Yeah.
No, 5000 watts, but per hour it's not required that much. So based on the temperature. See, in the initial stage it took more.
Yes. Right.
Okay. In initial stage to settle down the temperature of room temperature. So then
Yes.
it may took
This much.
um,
5,000
so
or 1,000.
not 5000. Refrigerator is only, so this air cooler is only 1.5 kilowatt or more or less.
The centralized we use.
Yeah, you are using centralized.
Yes.
Okay, centralized, it requires more.
Yes. We can use the minimum, the bare minimum.
So normal is there, na? Normal means
Yeah. The AC, the normal AC. Yes, we have.
uh, 1 second. It is not editable. Okay. Uh, do that layout. Yeah, is it visible?
Yes.
Okay, fine. So then here, total, uh, I will show one basic research paper today. So based
Sure.
on that, we'll discuss. So actually, I implemented recently one paper, which is related to your area only.
All good.
Uh,
Yes.
I will explain about my paper.
Sure.
So then you will get some idea. Based on that, I will move. Progress. Okay. Components. Performance. Study. Yeah. See, is it visible?
Yes, it's visible.
Hmm. See, recently I published one paper. So
Sorry.
the title is this one: Performance Study on a Small Scale Solar and Wind-Based DC Microgrid.
Oh, that's your paper?
Yeah.
Wow, nice, very good. Inshallah.
So it's a base very similar to your paper only.
Yes,
Then here, just I want to tell you what I did here. Okay. So then same similarly, we will go to your project also.
yes,
So this in the initial class, I shared you this one.
right. Yes,
So here, uh, uh, I consider here in the abstract, you will get it. So the DC microgrid have become increasing popularly as means delivering reliable. I told you, na, reliable means it's available everywhere.
right.
So as well efficient power to remote areas such as residential loads, so then educational institutes and health centers. And DC current microgrids includes various energy sources such as solar, photovoltaic, and wind energy generation. Okay, so a battery energy storage system and a controllable grid tied electric vehicles. Okay. So
Yes,
in addition to the uses of compact fluorescent, these are the loads. Okay, CFL lamp, then light emitting LED bulbs, then the refrigerators, TVs, fans, air conditioners, okay, laptops and other devices in a home.
yes,
Okay, so
yes,
in a homes and workplaces, constantly increasing DC loads in a building. Already I told you the most of the nowadays whatever we are using the loads that and all are DC. Okay.
yes,
So so in order to supply electricity to remote residential areas, so I did small work only. So it means it can offerable and normal these क्या बोलते हैं वो? What? See, there is a one line is there that I forget that line. So normal people also they can offer this. Okay, normal people means those who have sufficient money to them, so they can also build
yes,
this thing. Okay, in
right.
order to supply electricity to remote residential areas, this research proposes a DC. I told you now we have to
Yes,
in the initial class
yes.
I discussed with you
Okay.
there. See, Abdul, meanwhile, whatever I'm saying, you better to write. If you have possible to write in any paper, you better to write these things and all. Why? Because not only the recorded classes, whatever you wrote, then it will be stored in your mind. Then when you are going to meet your doctor or professor, then you have to, then at that time you can tell these things to him. So then he will also feel that, okay, my student is doing good project only. So then, meanwhile, he might give some suggestions to you also.
Right. Yes,
But
I will write. I will.
Hmm.
Yes. Yeah, I prepare the pen, the paper.
Yeah. Or else I will forward it to this guy and he will forward it to you. Okay.
Yes.
So this is the thing. What happened means it's a grid. See, this research paper proposes 48 volt standalone DC microgrid. This is islanded mode only. Okay.
Yes.
So then that operates only in grid connected under various connections.
Mm.
So the primary
Okay.
objective of this work is implement the domestic level DC microgrid in rural and remote areas which utilize the renewable energy sources. The proposed
Yes.
DC microgrid was designed simulated successfully in various loads using suitable power converters, and this proposed microgrid performs in the MATLAB. Okay, so these are
Yeah.
my abstract. So then when coming to the modeling, I told you no modeling.
Yes. Right.
So
You told
this
me.
is the modeling one. Okay. So modeling
Mm.
means we have to choose the solar. So then we have to choose the first sources. What are the sources are there? So then here I choose the solar photovoltaic. So then wind turbine generator. So then here UPS battery is also source. I told you it sometimes it acts as a source. Sometimes it acts as a load.
Load. Right.
Okay. So then I consider these things under. So this is the modeling. What should we have in our work?
Right.
So then this one is the modeling as well as the designing system also.
Correct.
Okay.
Yeah.
But so then I'm coming to this table. This table is visible.
Yes.
Yeah. So
Mm.
just I'm zooming it. Okay. Now is it visible, Mister?
Yes.
So
Yes, I can see
okay,
this.
here see the here I consider so modeling means I consider here 1 kilowatt solar,
Yes.
1 kilowatt wind. So
Yes.
solar means four series panels on on a parallel panel. It's multiplied with 1 kilowatt. Then wind turbine means I consider 1 kilowatt. So then 100 watts. So then this is the details of this and how much speed it will run. So maximum speed and the specifications of UPS battery. Then 48 volts. So then 10 mAh. So then 10 Ah. Then SOC means that battery level should be in 50%. So then
Yes.
specifications of EV battery, then I consider 76 volts. So then same thing. Then a boost converter I consider. So here total we have one solar, then I consider 1 kilowatt. So
Yes.
then wind is there, then I consider 1 kilowatt. Then UPS battery is there, I consider here 48
48 volt.
40 volts. So then EV is there, it's a 72 volts.
Right.
Okay. But here
Yes.
here I consider DC the boost converter and bidirectional converter.
Oh, right. Right. Yes. Yes.
Okay, this is the modeling, Mr. Abdul.
Mm.
Okay, so then we have to do these things. So then, meanwhile, uh, for suppose if you consider a normal load or normal house, so then nowadays, then I consider these are the loads. So I think in every home initially we have this type of loads, right?
Yes.
So in your
Uh,
home, LED bulb, small
oh,
one is there.
yes, we have.
So then
Yes.
LED bulb, large one is there, which is the
Right.
high amperes.
Yes.
So then
We
a
have.
CFL lamp is there, 12 volts. Then current is this one. So then television, TV, 12 volts.
Yes.
Then this much amps. And this is the power. So then this one is the here. Okay, the cell phone at 4 watts. Then computer 170 watts. Then exhaust fan, ceiling fan. Then vacuum cleaner. Then water refrigerator. So water purifier, refrigerator, washing machine, water pump, electric vehicle.
Yes.
So these loads we should first of all we should in the modeling. So in the modeling I said you in the modeling. So first of all, based on the loads only, we are going to see based on the loads means whichever the applications are, whichever appliances are there in our home. Based on that only, we are going to build our microgrid.
Correct.
See,
Yes. Right.
whatever you said, the one thing per month 3.3 kilowatt we are using. So more than that you can use, less than that you can use, right?
Right.
Then that's why we have to do some modeling. So then next time, say I'll forward this paper based on this paper. So then tomorrow, next class when we are going to do, when we are going to take a class, at that time you just to spend some time. I'll forward this paper to you. Spend some time. Spend some time. So
Mm.
then you have to work it out. So then just to list out the appliances are there, which are appliances are in your home, in your personal home. So
Okay.
then only we'll consider. See, don't consider this office, that office. As a normal human being, as a normal family, how much load we are going to use? And that is main because you are going to implement in real time. See, it's not
Yes.
only
Right.
simulation. See, so not only this, you can consider your home or else your doctor office. or else your electrical and computer science department is there na, in your university.
Yes.
You can see, first of all, you just take a small one, because if you take a large one, then you have to define a lot of things.
Correct.
So
Okay.
first of all, design and define the loads of it. So then here we consider these things and all. Let's say in normal home, everyone have to bulb raised. Everyone have CFL bulb. Everyone have TV, cell phone, computer, ceiling fan, exhaust fan, vacuum cleaner, water purifier, refrigerator, washing machine, water pump, electrical vehicle, right?
Right.
So
Yes.
then, based on the loads here, you're observing or not, based on the voltage, based on the current, we have to choose them.
Right.
So total, how
Yeah.
much power you required, first of all.
Okay. I
So
will. I will do this.
yeah.
Yes.
So when you finalize this, for suppose whatever you said 3 kilowatt means, so if your load is 3.3 kilowatts or 4 kilowatts per month, okay,
Yes.
then based on double means you have to build a minimum 6 or 7 kilo or 8 kilowatts PV panel.
Oh,
Then
okay.
it's a huge amount. Why? Because
Yes.
so parallelly, then we have to keep high capacity batteries also, right? Then why? Because
Okay.
so based on the loads means, if we have this much load in your home, uh, then what you are going to do? Sir, whatever, see, if you have this much loads, already you are paying some amount to the electric board. So then again, you are going to install these things in your home or in your near places or in your circumstances. So then, what is the benefits between those two? That's why you have to do small experiment. So
Right.
then, just to identify the loads which you have. First of all,
Okay.
either you are considering a home or this farmhouse, or considering any normal home. So, okay,
I,
basic normal home. So then they
yeah.
have two
I will.
lights,
Yeah. I will try to consider like a normal house, like one floor, one
one
floor,
floor.
small house. Yes. I will
Hmm.
consider this houses
Uh,
and to minimize the load.
yeah. So then you should calculate the total loads. Okay. So based on that loads only, then you have to do these things.
Sure. Yes, I will.
Then
Okay.
based on this, see, so total my power is this, but I am not operating at a time these loads. See, your entire load is 4 kilowatt, as you said, but you are not running at a time the total load.
Right.
So this is called operation, this is called scheduling, this is called load scheduling.
Hmm.
So you have to do load scheduling. For suppose now you are not turning on your fan, now you are not turning on your refrigerator, now you are not turning on these things and all. Why? So you are now studying. You need only one lamp. If it's very hot, then you need normal AC or a normal cooler. You don't need
Right.
remaining loads, right? So
Yes.
this is called load scheduling. So then this one. So first of all, we have to identify the loads. How much loads are there? So then we have to define that load curve. Okay.
Yes.
Then we have to do this modeling. With that modeling, we have to give these specifications and all.
Yes.
So when you do these two things, these three
Yes.
things, okay, loads, so then specifications of your system, this modeling, then your project 50% is completed.
Oh, okay.
Yeah, there's nothing is there. See, if you know these things, then we have to study. Just we have to study about solar, how it comes solar, when it comes, then how much power it generates. If is there any technique is there to extract the maximum power? One technique is there, MPPT techniques, maximum power tracking, right?
Yes. Right.
So then, if you use then the techniques, there are two types of algorithms are there. P and O, Petrobu optimization algorithm is there, and then incremental conductance algorithm. There are two types of algorithms are there. Then if you use, then which type of algorithm is suitable? So then based on that, we'll go to that algorithm. Then which algorithm will give more efficiency? So then we're going to study that solar.
Right,
So
right,
then,
right.
then we will decide the how much kilowatt solar is required. So then afterwards, then we are doing these things. Okay. So then
Yes,
say here also I did modeling. So solar photovoltaic modeling. So here see the SPV is one of the most environmental friendly and reliable beneficial way to meet load demand in the remote locations, right? So
yes,
solar
right.
PV determined based on the prevailing the ambient temperature. So then under
Yeah,
solar radiation levels, then this
right,
relationship can be defined by using this one. So then wind generation also similarly. How we are going to
right.
do wind generation. So then third one, the battery energy system, how it's work. So they will give some equations. What is the SOC, state of charge, then a minimum, what is this time, then what is the maximum. Then we'll do some equations and all. We'll study about this. Then load profile description. What are the loads are there? What are which type
Mhm.
of loads are you doing? So then after this, then we'll choose one method that is called a proposed method or proposed system. So then here we did a proposed system. So then what are the what we are going to propose in the new system. So in meanwhile, so here I proposed one thing. So then how it looks and what is the consumption of energy, what are the conservation of energy. These things I wrote here. Then after this is the main thing, right? Simulation results. So then based on that modeling, figure one is this modeling only, right?
Yes, you
So
just
this
so yeah.
yeah. Uh,
And
Yeah,
the modeling, yeah.
uh, figure implemented in
Okay.
MATLAB environment. Then following section source results. Then case studies. Hybrid mode. See here, I haven't considered grid connected mode. I consider only islanded mode or standalone microgrid only. Okay.
Mm. Yes,
Here I never
yes,
consider the micro. I never consider the grid.
yeah, right.
So then a hybrid system, residential buildings with BES and SPV, it is implemented to evaluate the effectiveness of the system and the dynamic power sharing strategy. So then the simulation results are case studies. So here I told you na operation or analysis. Did you
Right.
remember that things?
Yes.
Yeah, how
Yeah,
we
I
are going
remember.
to how we are going to operate or how we are going to analysis. See, you have to test your system, right?
Right.
So here I did the some case studies here. So first in the case one, in case one, solar is present. So then wind is present, battery is present, and
Load is
loads are present. But EV is charging mode.
right.
Okay. In the
Yeah.
case two, uh, solar only there, wind is absent. Then battery is there, loads are there. Then what is EV doing? Only
Charging.
charging and
Charging.
discharging.
Yes.
Then case three, solar absent, only wind is there, then battery is there, then loads are there. What is the EV condition? Charging
Charging
and
and discharging.
discharging. Then case four, solar, wind, or battery, there is no. So only loads are there. How we are running the loads by using EV. So then it's a discharging.
Okay. Just to make sure the EV battery is the same as the one we use for charging electrical cars, right?
Oh, same only.
Yeah. Same.
See, for suppose how it's doing, how it's working means now your office time is over. Okay, your job is over. But
Yes.
in your electrical vehicle car, EV car, you have 90% or 100% SOC battery level charging.
Yes.
So if you leave that, it will get drained.
Right.
So then, in your home or in your place, there is no solar. First, if it's a rainy season, there is no solar.
Yes.
There is no
Yes.
wind. Already battery is over.
Yes. Right. It happens.
But you need to electricity. How will you do? You are in the home only.
Oh, okay. By using our a car, a car battery.
Yeah, by
Mm.
using our car battery,
Yeah.
we'll connect to the system. Then we call it emergency loads or uh, emergency loads only. So one light, one refrigerator, or one, based on that we are scheduling loads. So based on our battery capacity, how long it will come. So how long it will come means how many loads we should turn it on. So then we should think, and we should do that things on that particular time.
Clear, clear, yes. Yeah.
So here, this is the see the this is the solar characteristics. So then I consider 24 hours. Here around 6:30 it's closed. Around 5:30 it's 5:40 it started.
Yes, right.
Solar irradiance.
Mm.
Okay. So
Okay.
then
From where to get these pictures? Like,
uh,
is there
uh,
any,
so
uh,
this pictures means we have to design the load characteristics. This,
okay, yeah.
so we should give this to MATLAB Simulink.
Mm.
It will
Yeah.
generate like this.
Okay, okay, okay.
So it's a real time data, like how sun is giving temperature or irradiance.
Clear.
Hmm.
Yes.
So so based on these things, we are going to do same similar these things only. Wind speed, how sometimes it's a fluctuating. So then we have to do this wind speed also for 24 hours. Okay.
Yeah. Right.
So here case one, profile of solar and wind. Uh, this section A, profile of solar and wind. How this is the irradiance. Okay,
Yes.
irradiance temperature only. This is the wind speed.
Right. And these two
Then
combined. Mm.
yeah,
Mm. Yes.
then here a solar and wind and a battery power generation profile. So how the batteries and power will generate. So first we shown you already, this is that irradiance, right? So based on that irradiance, by using MPPT techniques, we are getting this power.
Yes.
Okay.
Right. Right.
So based on this wind, we are getting this. This is the power.
Yeah. 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 Yes.
So so then this one is the battery one. See, this brown color represents wind power. So then this blue color represents PV, how it's generated. So then battery is there, na, green color. So did you get any
Yeah.
doubt here in this picture,
I
figure
think
number 3?
I think it's for discharging,
Where?
for the down, for the minus or some, or below the zero.
Yeah. See, the basic timeline is there, na. So the where the basic timeline is there. So here, whatever the negative is there, na, it is the discharging mode, right?
Yes. Right.
So then when is a positive cycle is there, so there it is a charging mode.
Discharging. Yes. Yes.
So so it's a generation only.
Yes.
So
Right.
see, whenever the wind power is there, at that time the battery is getting discharged. So why? Because there is no solar generation here.
Yes. No
Are you
solar. No. Yeah. Yeah. Because it's yeah.
so like that only. Uh, so same similarly, you can observe these things. So how it generates, how it's the energy storage, so how the energy will store. See, when the solar is high, at that time the battery is in positive side only, right?
Yes. Right.
So, so similarly, our load should be like that. So this one is the
Mm.
case one only. So then when you, so already I say to you, na, there are four types of case studies are there. So that case
Yes.
studies we are going to do. We are going. Say this. See, the A and B are only generation profiles. right?
Yeah.
So then here the case studies are there. So loads utilization combination with all power generation sources. So in this case study, all are present only, na?
Yes, 4 cases. Yeah.
Yeah, case one. See, Wahab, in the case one, all solar, wind,
Oh,
battery, loads, and EV are all are present, right?
right.
So here also the same thing. See, here all load is there. So then solar
Yes.
power is there.
Yeah.
Then
Four of
battery
them.
is there. Wind also there.
Correct. Yeah, right.
Okay. So then you can observe here how the loads, when the loads are high, the battery will get discharged. When the power
Mm,
generates, see when the when the loads are required, so then battery automatically it will get discharged, right?
yes.
So in the
Right.
daytime, our home or household will be closed. At the time, our battery is going to charge. So our solar
Right.
power is high. Normal loads are running. So when the loads are running, the battery is going discharge, right? You observe. So
Yes.
if you observe this, then you will get how the performance will going to do these things in real time electricity.
Okay. 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 Yes. Yes. Yes.
Okay.
Clear
The
now.
same thing, loads operated by combination of solar and wind, power battery only. So then only when the solar, wind is absent. So what is there? Okay. Which type
Yeah.
of loads are there? So then see the load profile is there same. So then all the things are going. See here loads are never decreased. The loads are same only. If you are observed.
Oh, right. Yeah. Yes.
See, even
Yes.
one source of energy is absent, it's nothing to worry about our things.
Okay.
But
Okay. Okay. Okay.
our loads are going constantly. So by the help of this solar and battery.
Yes.
So
Clear.
same thing, the loads operated by the combination of wind and power battery. The same thing here. So then these are the loads. This one is the
Without.
wind. So then
Yeah.
battery. The same thing. So here the loads are also constant. So then
Correct.
one more performance is the EV to building. So here, see, one is battery charging SOC. So then one more is a battery charging SOC, discharging.
Yeah. One charging, one discharging.
Hmm.
Right.
So then we have to maintain the our DC bus constant, 48 volts, right?
Yes. Right.
So this is the in conclusion that the research 48 standalone simulated MATLAB software for this new design of DC microgrid includes various energy generation sources, and these are the things and controllable. What I the primary objective of this research is design sustainable energy supply strategy for residential use. Okay, so this is our
Yes.
motto. This is our objective. You have to note down this.
Right.
See,
Okay. I will.
because you have to stick on this thing. If your doctors ask, if they are asked about these things, so our primary object is, our primary object is uh, to a design sustainable energy supply strategy for the residential use, right?
Right.
So then you
Right.
have to tell that thing. Then result of simulation, the proposed model was able to achieve. So whatever we are modeled, the model was able to achieve, right, the power rating which
Yes.
required by each of load. Then in the future this research can be improved by applying enhanced new locations in accordance with, and we can that means we can change in somewhere also. So then with the
Yes.
different design specifications, then we can increase the load, we can increase specification means we can increase the solar, we can increase the wind, we can increase the battery power, we can increase the load types, we can increase the load
Right.
capacity. Okay, so
Right.
it's different specifications. Then such as economic and environmental conditions. See, based on the environmental condition. For suppose, for in your area, you have more solar, you will get more solar, but you didn't get more wind, right?
Right.
So then
Yeah,
that's why such as economic and environmental condition. See, we can different, but when the economic, not only the environmental conditions. So we have to choose the environmental condition. For suppose in our area there is no wind, but you didn't get that much wind. Then, but if your propose is I'm going to generate a wind without wind, how without wind how can you generate the power?
by solar. But if we didn't have, we won't.
Yeah, so that's why. But for suppose, as you said, your load required per month means 3.3 kilowatt is there, na? So that 3.3 kilowatt, even you can prefer 3 kilowatt solar, 1 kilowatt wind. It's fine only, na?
Oh, 3,000 kilowatt.
Yeah,
Like,
3000
yeah,
kilowatt. Yeah,
yes,
okay.
3,000.
Okay, 3000 kilowatt. So for suppose you need, you have to build a majority solar only.
Yes, majority of solar, yes.
Because your environmental conditions surrounded by your area, surrounded where you are living, surrounded by where your location is there. The environmental conditions, what are the conditions are there? And you have to think
Yes,
about this.
yeah, sunny area. Right,
So then with that area, then you have to choose that thing.
right.
Okay. So then that then this research can be extended a larger system also, given and given experimental validation and an implementation of power system strategy take place to standardize voltage. Okay.
Mm, yeah.
So
But
then here
what does standardized voltage means?
standardized voltage means, see, in our electrical system
Yes,
there is some standard voltage levels are there. In the last class, to you and your the father, I took a class.
yes,
So in the AC system, there are in the for suppose in the generation there are standard voltage generations are there. 11 kV, 22 sorry 11 kV, 22 kV generations only there. With
right,
that we can step up to 400, 600, 765 kilowatt,
right.
kilovolt, not watt.
3 kilovolts, yeah. From kilo,
Okay,
kilowatt.
so that are the standards, but we cannot go beyond that. We cannot come beyond that. That is the
Okay,
standardized
yeah,
in the AC.
yeah,
In the AC also you have single phase and three phase. In the
yeah,
single
right.
phase, in the single phase, you have fixed 230 volts only. Why you can't go 250? Because standardized means already some IEEE standards and some electrical standards are there. But beyond that, we can't do. Even if you do also, then no one will use in the society.
Okay, okay,
For
okay, okay.
suppose, for suppose if you built a, for suppose after 5 years or 6 years, if you became a scientist, if you became a researcher, if you want to do a doctorate, or you
Yeah,
want to go and implement a new product with the different voltage levels, with a different input voltage, with different output voltage. Did anyone use that product?
no one will use it.
See, if you have single phase 230 volts, but you are saying that my product will work single phase 290 volts. Did anyone believe that?
No, it won't work. Yeah, no, no one will
Yeah.
use it.
So that is called power system strategy takes place to standardize voltage. So here, that's why also I told you we have to maintain this DC bus voltage level. In the very initial class, I
Oh,
told you, na,
yeah, 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 yes, 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 yes.
what are the voltage levels are there? That level
48
only.
or yeah, yeah, 6 volt.
So,
Yeah, yeah, right.
yeah. So that
Mm,
voltage we have to do. So this
right.
one thing, uh, Mister. Okay. So
Clear.
then, this then up to this, what you have doubts, you just please ask.
Sure.
See what I explained till now.
I have one doubt. Yeah,
Yeah.
I just remembered. Uh, for the power rating for each equipment, uh, how could I find the current? Should I
Where?
like Google it? in the conception like applicances.
Yeah.
You have yeah. You showed
This
me
one,
like
huh?
yes.
Yeah, please wait. This one. Hello.
Yes, this one.
Yeah.
Yes.
See, you can find in the Google,
Hmm.
or else,
Okay.
or else. See, you have mobile phone, right?
Yeah.
So go on mobile phone. There is a one adapter is there, right?
Sorry.
Adapter, mobile charger.
Yeah.
You
Yes.
can you can find in the adapter nameplate details of your adapter. How much power
Okay.
is there?
Yes.
So then
Yes.
here television is there. Backside the television or in the top of the box television, you will get it.
Mm. And should I check the input, right? Not the output.
No, see, Mister, you have to classify these things. See, if this is
Yeah.
same paper, I will share this paper with you to remove my names and all. Okay.
Yeah.
I'll share same this paper to you. I'll remove my details and all.
Okay.
So then you just take a printout of it and go and submit to your doctor. So then before that you read, before that whatever I said, you just remember that thing. If you discuss with your professor, then absolutely will accept this proposal. So then based on your loads, this is you just you said, just you convey to your doctor, sir, this is my proposal to do the project. Then what you say? These are my loads. These are my system modeling. These are my analysis. So these are I'm going to do. This is my basic paper. This is my reference paper to do the project. If you say na, then he will give some inputs. Based on that inputs, then it will be good to you. Why means
Okay.
he will only giving going to grade to you, right?
Yes.
If you see, if you satisfy him, some if you meet regularly him, if you obey him, if you satisfy him, he will give good grades to you also.
Right.
So then, because sometimes the student mentality, what they are doing now, I know the project, anyhow, hook or cook, do or die. I did the project, then I'll submit it. Na. So then there is no use of it. When you are good relationship with your doctor, so at the time in the panel when you are going to present, at the time they will ask what is the load, what is the modeling,
Right.
what is the analysis, what is the
Right.
operation, how you consider this, how can you say based on our UK government, how, how you are going to do. If they ask these type of questions in the review or presentation, what will you say?
Right. I have to understand it. Right.
Yeah, see, you have to say see, I am saying
Mm.
that don't spend much time about it. We are ready to help you. We are ready to
Yeah.
train you. We are ready to try, teach you. We are ready to give whatever you want.
Right.
Meanwhile, but we can't come there and give your presentation.
Right. Yes.
So you have to give your presentation. See, you have to
Right.
get excellent grade.
Correct.
So then these things and all. See, minimum. See, I'm sharing my knowledge. Whatever I have knowledge, I'm sharing with you. So from scratch to excellent. So that is knowledge you have to apply with your doctor
Yes.
simultaneously.
Yes. I usually go with meet with him. Yes.
When you are meet with him, then he will, if he say some corrections and all, if you convey to me in the class session or in the by the help of that Aditya, so then we can get then only we can do the whatever the doctors your doctor is required.
Right. Right.
Okay, see whatever the see one more thing also I'm telling to you, Mr. Wahab. See, see,
Yes.
I did this project. I wrote a paper. I submitted to IEEE. Then it's published already.
Oh, okay.
It published already. See,
Yes.
if you whatever you are going to do the project, the same project, if you write a like this paper, any IEEE conference or small journal in your area, in your country, your
Yes.
doctor will happy. You will get good marks. You will get good
Right.
knowledge.
Right.
So then you have to
Yes.
do that thing. But we are here to help you. Nothing to worry. So whatever,
Mm.
see, first of all, see, Mister. First, you find out these. Say today, see in the first class, I discuss what is the microgrid.
Correct.
Again, I'm
Times of
recalling. Again, I'm recalling. Okay, I'm recapping the
yeah.
entire things. First, what is the electrical? What is the power system?
Yeah,
Then
it's a generation, power transmission, power distribution, power transmission.
utilization. So then when it comes to what how many types of power generations are there? How many types of transmissions are there? So then what are the distribution? What are the utilization? So then
Right.
so if it's are there, then what is the microgrid? There are types of microgrids. Super grid is there, smart grid
Yeah.
is there, then microgrid is there. Then what are the difference between these? So then why
One is
so then
right.
super grid is means it's a huge one. It's connected to the one country or one nation or one uh, one separate
Yeah,
ASEAN or like that.
right.
So
Right.
then smart grid means it's a
Knows where.
communication.
Yeah.
It's a communication between the loads and the sources, which are going
Right.
where the faults are happened. It's a smart grid one. So it gives the information to the electricity board. Now
Yeah.
we can call it as a SCADA. Did you heard about SCADA? This
No.
CAD, that SCADA will come under smart grid only. So then we came to microgrid. What is a microgrid? It's a network. So then
No.
it's a
No.
combination of sources and loads. Then again we came to the types of uh, microgrids. One is the AC microgrid, then second one is the DC microgrid. Then what?
Yes.
First of all, what is the AC microgrid? Then what are the sources are there? What are the loads are there? Then how we are going to do? Then what is the performance of it? Then why we need to go the DC microgrid? And then what is the advantages are there? And what are disadvantages there in the AC microgrid? We studied that thing. So then
That's fine. So,
again we came to DC microgrid. What is the DC microgrid? DC microgrid means this one. These are the sources. These are converters are there. The loads are there. Nowadays everyone using the DC loads only. So that's why the too high efficiency to get reliability. So then the smaller size. So then the operational and maintenance cost is less because of these constraints. Then environmental things and economical things. So to includes in the DC microgrid. So then based on this, we are
right.
going to improve in the DC microgrid. So then the DC microgrid, in the last class also, when you were friend and you were going to take, you both taken class, and at that time also we discussed it briefly. Again in the
Yes.
last class, in the same class, I discussed in the about solar, how it generated. There are two types of solars. Uh, so
Thermal.
one is a thermal one, one is a photovoltaic. So then
Right.
what is the what thermal did what a photovoltaic will do. So then
Right.
I told you then how it's operation. So then again today we came. So before in the last class I gave one assignment to you. Then you say the loads, but these loads are okay. But if you have two floors, if you have three homes, if you have a huge loads, that is the required. Then what about the basic one? See, in anything basic one only. So then whatever I did the project which is related to you, whatever you want exactly, that project I presented to you Heroes today.
Yes.
So this project, so the same this project we are going to do with different specifications, different loads.
Right.
So the meanwhile,
Yes.
see, see, in the next week after 27th, I will be available.
Yes. Yes. We
27th,
can do it.
27th of this month, I will be available. Okay. So I'm going to my hometown for to
Yes.
celebrate the Christmas.
Yes.
So I'm not available. So then my now I want to give some one conclusion and some assignments to you. So then
Yes.
we'll wind up the class today. So then what I'm going to do means first of all you have now you have 50% of idea about your project.
Right. Yes. I have.
50% of idea.
Correct.
What is electrical? What is power system? What is microgrid? Types of
Yeah.
microgrids. So then what is solar? Then we just we have to study briefly and thoroughly about solar photovoltaic, how it works. So the next
Yes.
within 4 to 5 classes we'll wind up your project
Oh,
about
okay. Okay.
theory explanation.
Yes. And then we will design it.
Next class we are going to do, we are going to discuss about solar.
Okay. Okay.
One more next class we are going to discuss about wind, how it generates. That's enough. One class solar,
Yes.
one class wind. Then one more class converters.
Yeah.
So then
Yes.
again, and if we take one more class, then we will wind up. We'll take the final system. So then we'll come into one idea. Before that, I'll give some questions to you. You find out it. Then you better to make any PPT or Word file. If you make
Yeah.
it, if you make it and forward it to him, he will send it to me. So then, based on that, I'm going to teach you.
Okay.
Because whatever, see, I can teach you theory. It's nothing, Mr. Wahab. See, in the realistic, I'm explaining with my paper.
Yes. Right.
So this one only you are going to do, right?
I will do, I will design the system, but not like this. I think in the Simulink.
Yeah, see, you are not getting my words.
No, I
You
will
are not.
do. Yeah. Yeah. I understand.
No, no. These things, where I did, these graphs
Where
where I got.
from Simulink.
Yeah,
I know. But what I meant is that the design, the modeling,
yeah. See,
the
yeah.
designing of
So
the system.
designing model means, um, see, okay. If it's not take that much time, I will explain to you the files.
No, I will send you a picture for a related one for my studies.
Okay. You send a paper later. Okay.
Okay.
Then based on that, we'll decide.
Okay.
Now just
I,
I will show you. Just be in a line. You have any urgency? No.
no, I'm free now. I send it to
Okay.
Agrawal. We can see it later or anytime. It's like this one. It's
Yeah.
from Simulink.
Yeah. Yeah. Just modeling only. I'm showing to you. Okay. I'm not going to run and I'm not going to explain. See, you have doubt now. Simulink one. That's only I'm going to show you.
Okay.
Okay. So anyhow,
Yes.
so this one is I'll forward it to this paper to you. Okay. Today.
Yes.
Just go thoroughly and ask your professor and do the modeling of these things and all. So then when it's okay, then based on that we'll going to do our project.
Sure. But my professor is on holiday. We are on holiday for 1 month.
Okay, okay. So if you have any base paper, then you send it to me. I will
Sure.
work it out.
But what I meant that the system structure of DC microgrid,
Uh,
this is a basic one, this is a basic one, but what I want to do, I'll send it to Agrawal just now. It's one with the BV, the wind turbine, the MBBT, the transistors, the battery controller, or the yeah, and the battery and inverter, control of inverter. Do you understand me?
See,
The load.
yeah.
It's
Just now,
simple one.
just now I got from Aditya. See here, one PV is there, Mister.
Yes,
PV is connected to boost converter.
yes,
So
right.
boost converter. So then wind turbine is there. With the help of
Yeah,
wind turbine, there is a rectifier is there. Rectifier
right.
is also connected to the boost converter. So they
Yeah,
are using only common boost converter. Okay,
yes.
I'm telling in your paper.
Yeah. I'm seeing this.
So they are connected. See, PV system output is connected to one boost converter. Wind system is connected to one boost converter. Okay, the same boost converter. So
Yeah,
then in the same parallelly, they connected to one battery with the help of DC-DC boost converter.
right.
buck boost
Yeah.
converter. So then meanwhile, say, is it visible, Mister?
Not in your screen, but I'm seeing it my phone.
Okay,
With my
fine.
phone.
Okay. Uh, Here, see, in your phone,
Yeah.
SOC levels are there. Current battery, voltage battery. Then what are they there? So then here they connected to grid. So here not connected to grid, but they have AC loads here.
Yes.
But
Right.
for that AC loads, we have to use again inverter. You know,
Mm. Yeah.
see, from wind, from solar, it's generated DC power. So battery needs DC power, but here AC loads needs AC power. What I
Yeah.
am saying means avoid the AC loads and implement the DC loads. See,
Right.
same system we are going to model, but
Okay. Okay.
instead
Yeah.
of that, instead of this, see, just same, just
Yeah. Yeah.
and
Okay. Okay. We are going to do this one, but rather than AC load, we will put DC load.
yeah, say here your say you just see in the screen, Mister.
Yes.
See, same. You parallelly see the phone and the solar is there, wind is there, common. So DC converter is there. But what he did na, the whatever you share the picture, he connected to the direct this one. He didn't connect it to the this DC bus.
Okay. Okay. But. Oh, so you
Here,
want me to upload to submit this picture as my
doctor.
design?
Yeah.
How?
See, same
Uh,
one only. You are not. See, you are not get. My point. You are not getting. That's why. See, listen, Abdul.
yes, I will.
I'm saying.
Hmm?
Please listen. See,
Yes.
in your whatever you shared a picture, there is a solar is there.
Yes. What
So
type of solar?
solar panel, PV panel.
Yeah, there's like some kind of them. Like, what are the reading of it?
Yeah. See, for
Because
suppose
like I have to put some complicated diagram. Like I send it to you just like now. I can't submit
yeah.
this one my design.
No, that's why I will no the see this one is called as a block diagram.
Okay.
So this is the structure how your microgrid system will be uh,
Right.
there. This is the structure. This is not real work. See,
Okay. 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 Okay.
after designing in the MATLAB, so you are just you know open your screen.
Okay.
Is it visible?
Your screen or mine?
My screen.
Well, yeah, I'm seeing the structure of DC microgrid.
No, sorry. 1 second. Yeah, now I'm sharing. Is it visible now?
Yes.
So this one only you are going to asking, right?
Okay. Yeah. 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 This one is okay. Yeah.
So
Yes.
then I'm saying that only, na. You are not listening actually.
Uh, I
So
understand you that you meant I submit the diagram, the block diagram.
see, Mister. No, first of all, we won't submit this thing. First of all, we'll ask our professor about. So we'll share this one first of all to our professor. So we'll
Yes,
show
I
to
will ask.
these. So will show to same things to professor. Meanwhile, we'll give the specifications of that system. We'll give the loads to him. Then he will accept the thing. So afterwards,
Oh, okay, okay, okay.
afterwards we'll design in the same thing this manner. You have this. You shared this picture only, na, to me.
Yeah. Yes.
That thing only.
Okay, okay, okay. I understand you wrong. Okay, okay, yes. Yeah, yeah. Now it's
See,
good. Everything.
I am saying that will do. See, everyone will show this. See, in every paper, Mister, in every research paper, in every project, this should be there. This must be there.
Right.
This black,
Yes.
based on the black diagram only, we are going to design.
Yes. clear.
Afterwards, after designing that, the whatever we designed, then we can tell or we cannot tell that thing. See what we use and what we. So that's why we are telling these things and all. Na? See, in your if you are observing your phone, whatever you share the diagram with me, so
Yeah.
converter is there. So then
Right.
in what you shared in the picture, the converter is there, but they showed a real converter. The what is the converter is there, but we are writing this converter. This is the DC-DC converter, right? But
Yes, yes,
we are
yes.
not drawing this diagram.
Right.
So
Yes.
so that is we can reproduce to them.
Okay. I will after I get the loads specification of the loads, I
Uh,
will send email to the doctor to accept if he accept it or not.
yeah. So based on, see, if we do any see, Mister, I will show one more diagram to you. Then you will get
Sure.
some idea. Yeah. Is it visible?
Yes. Oh, yes.
This one only, na? You are asking,
Oh, yes, 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 yes.
isn't it or not?
Yeah.
So this PV is there. Boost
Mm.
converter is there, DC-DC. So the rectifier is there. DC-DC boost converter is there. Battery is there. DC-DC bidirectional boost buck boost converter is there. So then these are
Mm.
the loads. Then here we consider the electric vehicles as the loads.
Right.
So we can draw
Okay.
this type of diagram, or else
Mm.
we can produce this type of diagram. Okay. Or
Yes.
else we can show them this type of diagram also.
Right. Yes, we can. Yeah. Correct.
Okay. So that
Yes.
is the
Clear.
thing. So just you take a note of these things and all, and submit to them. So then
Okay.
what your doctor says, then after 27th or 2024, you contact me. So the based on your specification, we'll going to do. Why? Because the electrical system is it's a huge sea.
Mm. I just want to make sure my doctor is on holiday till 22 of January.
Okay.
So one
Then
month.
you can mail him.
Yeah, I will email him, but he might not respond. But I will email him.
See,
Okay.
just to send these things as well. This is my reference. What you just give
Yeah,
assure to
I,
me.
I know, because I emailed him multiple times and he didn't respond. So
So
that's why I'm.
anyhow, see, next time uh, it should not blame the doctor should not blame us, na? Why? Because we have to do our duty. If it's not respond, then it's his mistake, not your mistake or my mistake, right?
Right.
Yeah. Okay. Any doubts till now?
No, all clear.
All clear. So you just do that job. Okay.
Okay.
So then when you're so you just identify the loads and system modeling. So based on
Yeah.
that, we are going to design our system. So based on
Yes.
that only, we'll move further.
Okay.
Okay, you
Sure.
just keep a note. So by the tomorrow morning, I will send the paper now because I have to do some edits on in this paper. After
Yeah,
that
sure.
only, I'll send it to you. You just
Sure.
be patient. Say I
Yeah,
will
sure, sure, brother.
surely I'll send to you by the
Okay.
tomorrow. Don't worry about this. Then I'll share these things to you. Okay.
Yes, thank you so much.
Okay. Bye. Thank you.
Have a good day. Have a good night.
Yeah.
Have a
Yeah,
good
bye. Bye.
day.
Yeah. Aditya. Yeah. Aditya, please close it now.
Okay, okay.
Yeah.